Okay, I've been asked to do 2834 off the practice test, and on the very last page of practice test 4 and 5. So we are trying to find a value of c that will make this function right here continuous at 4. So the part that is most important to do is do the limit as x approaches 4 from the left of the function, which is less than or equal to up here, which means you're going to plug 4 in right here, which will be 4 squared, which is 16. And then you're going to do the limit as x approaches 4 from the right side of f of x, which means you're going to do the bottom one, and this is going to be c over 4. So in order for these limits to be equal, c over 4 has to equal 16, which means c would have to equal 64, which would be the value that would make this function continuous. Because if you do up here, plug 4 in for f of 4, you get 16. And when you plug 64 and you divide that by 4, you get 16. So all of them give you 16. All of the 1, 2, 3. This is part 2 of the 1, 2, 3. And 3 would be true too, because the first statement would be equal to the limit. Coming down here to number 34, you plug 0 in. For the second term. Then we distribute -2, and we get -2x minus 2 delta x. And then we get +1. And then we go ahead and we distribute this negative to all these things, and we get minus x squared plus 2x minus 1. And on the bottom, we still have delta x. So all I got to do is combine like terms. So if you look here, I got a positive x squared and a negative x squared cancels out. I got a negative 2x and a positive 2x cancel out. I got a positive 1 and a negative 1 cancel out. So now everything has a delta x in it. So I'm going to factor delta x out of everything in the top because my goal is to get rid of the delta x in the bottom. So when I take a delta x out of this 2x delta x, I have 2x. And then I got +1 delta x stays there, and then I have a -2. And on the bottom, I have delta x. These reduce to 1s. And now when I plug in the 0 into this term right here, I end up with this is going to equal 2x minus 2. And that is the solution we're looking for. Now on the back side, this says take f of x, and it's got a horizontal shift right. So I can take all these points and move them to the right, but a faster way to do it is take my y-axis and move it to the left one, which will move all of the points to the right. So this is I'm going to call it y prime because this is my new y. And then this is 0 here, so now this is 1, and 2, and 3, and so forth. So we want to do the limit as x approaches 1 for f of x. So my 1 value is right here. So that, okay, now that looks like we may not have an answer on this one, but we're gonna do the limit from the left of this thing. So I got to do the limit as x approaches 1 from the left. So let's see, this is going to negative infinity is what it looks like. So this is going to negative infinity. Not exist because you can't, they both aren't going to be going to the same place. On this problem, this says we have to take the f function now and all the points are moved to the left, which moves the y-axis to the right one. So I'm going to take this y-axis now and move it over to here. That takes all the points that were on the graph and moves all the points left one. And we're going to approach 1, and I can't see that, I got to get my glasses. We're going to approach 1 from the right side. So that's a plus sign. So as I approach one from the, well, here's one right here. This is one. So as I approach one from the right side, let's see, that's going to be 1, 2, 3. So this part on top is approaching 3. And then this is g of x. This one is moving all the points left 3, or I can take this y-axis and move it right 3. 1, 2, 3. So it's going to come right through here. And so this is -1 here, -2, and the y-axis is -3. And I'm going to approach 1 from the right here. So let's see, 1 is here. So from the right, we're coming down this way, and that value is -2. So that's going to be -2. So this is going to be my solution for number 5. Hope that helps. Talk to you guys later.